Hey everybody, welcome back today. I've got a special new CRT video that I'm about to show you, and I just want to introduce it a little bit by saying this is probably the most difficult and tedious repair that I've ever been able to complete. It's on a very special CRT monitor that is rare. It's a Mitsubishi 37-inch presentation monitor. So this is something that would have been used to give presentations, and it's a commercial grade monitor, so it does have a lot of the things that like BVMs and PVMs do, where it has those professional inputs and you can get higher resolution video on it. But honestly, the condition it's in right now is kind of a mess. I'm going to go in here and show you around my storage area, and we're going to look at this giant presentation monitor in the vault. All right, one more thing before we look at this presentation monitor, please, if you enjoy this kind of content in these videos, do consider helping me out by hitting the like button on this video. It does help the reach and the algorithm. And also, if you like CRT repair videos, consider subscribing to the channel. And if you have a CRT that you want to get fixed or worked on, or have some kind of CRT questions, I'll get into how you can get in touch with me at the end of the video. I'll give you some more details on that. But for now, let's just jump in to check out this 37-inch Mitsubishi presentation monitor. We're here in the CRT vault. I have some company. We've invited Cole to come out here with us and check out things in our big room here. Wow, lots of CRTs. So this is a Mitsubishi presentation monitor, and it's pretty rare because there's not too many of them around, and the reason is, again, that they're so large. They're hard to deal with a lot of times. This thing weighs a few hundred pounds, and it's not really something that I could even move around here by myself. It sits on this cart, this heavy-duty cart. That's where we'll be working on it here in the vault. This is the XC-3715C color display monitor. It is pretty universal for power, all the way from 100 up to 240 volts, 50/60 hertz. And if we can find any other information on here, there's made in Japan. If we look at the input board down here, it is pretty amazing. Look, so here's our switch, I guess, that in there, I don't know, I can't really tell, there's wires over it, where it's either going to be set for maybe this voltage or this voltage. The client tells me that it keeps blowing fuses, which there is a fuse right here, a cylinder that would hold a fuse. There's our power plug input, and that's really all I know, is that it blows fuses. I told the client, as he's a longtime Patreon member, that I look at this thing, but the the confidence level I'll be able to fix this is really unknown. So we'll just see what happens. But since it's here, I wanted to document it for sure. We have regular inputs for composite video in S-video form, in composite video, and then we have analog TTL. We have another analog 1 input that does RGB, and it looks like we could do composite sync or C-sync maybe. We're going to start by taking off the outer shell and taking a look inside. Looks like it's all just Phillips head screws, and we will see what we've got in there. And what do you have down here? What did you find? Oh, great, a piece of, oh, that's just a rock. You're chewing on a rock? What's wrong with you, boy? All right, I've removed the shell, and we can check out what's going on inside of here. This is quite, quite an interesting thing to behold here. We can start from the top, I guess, and work our way down. We have the anode cap, and it's obviously been messed with. I mean, it's barely hanging on here. So that's not really good. Should definitely have less of this goop on it, and it should have a better seal. So that's not really good. I don't think that's blowing the fuse, but that's interesting. Oh, for some reason we have electro glue goop down here. A lot of this at the flyback here, so I'm not sure if there's like a flyback arc going on. Obviously that is the flyback, and we'll probably be able to expand out and look at some of these boards more closely. This would appear to me to be the power supply, if I had to guess. I mean, there's a lot of voltages you can see over here that are coming out of this board. Tons of different voltages. And just look at this board. I mean, it's a mess. There's a lot of like, looks like some of these caps have been reflowed on solder, but a lot of these points look super dull. And I just don't even know. I mean, some of this stuff has got to have bad solder joints on it and probably bad components. Look up there, we got something that had to be repaired, a botch right there. And that's all got to be power related. This is the input board. Man, that power supply board is just a mess for sure. I mean, I can tell that's the power board. And when the power comes in here, we'll see that it's probably just comes straight over here. So that's where the fuses are blowing. We can't even see the neck board, which also is probably a mess. It definitely looks like someone's been in here and worked on all this before. So it's hard to tell what the exact history is on this thing. And this would more than likely be the deflection board. And it, I mean, it doesn't look as bad. There's some dodgy stuff up here. But this is just, whew, goodness gracious. I mean, this is going to have to be, this is a risky thing, because we could rebuild this thing and not even get it back to working. I don't know. I'm going to clean all this goop off my hand, and I'm going to try to expand this area and get to this board. And that's really what I want to do next. All right, I've got this board expanded out here, and I am going to have to disconnect a bunch of these cables that flow over throughout the inside of the monitor. And there are some points down here I'll look at. You see, well, I can get these connections done pretty easily. Like, I don't know if I'll have to label them, but I wanted to show you, just, this is way too much electrolytic grease. Gosh, look at that anode cap too. That thing is a mess. Somebody really tore that thing up, and oof, look at it. It's ripped to shreds. It's got like 1,000 pounds of electrolytic grease. I'm not sure what can be done. That whole area should be kind of scraped clean, a little bit of that old silicone to help. But look at that. Good grief, man. Talk about lubing. I don't know if this flyback's even going to be any good. I don't know. Did somebody try to, like, yeah, they tried to squeeze on a different anode cap on here. This is one of the most bizarre. Somebody tried to service this thing and kind of screwed up on a couple things. I'm kind of unraveling here. Well, the complexity continues. So to get all this stuff out, there are boards that are just not, like certain cables are not simply disconnectable. You will have to desolder them to get them apart from the other boards. So we are forced to take at least this board, and I'm hoping that, like, there's not the case where they find that this is connected to even more boards. But I have to at least take this bundle and the neck board bundle also with me, just to take a look at the power supply safely in the other part of the lab, so we can diagnose some stuff. But that will also give us a chance to look over the neck board and see what kind of condition it's in also. Look at this tube here though. Right in there you got the shadow mask electron beam gun, which is 3 individual, let's see if we can get a good view, I don't know, inside there. So the Sony Trinitron guns is just like one kind of cylinder. This actually has 3 individual color cylinder heads in there, and that vacuum seal. And well, let's just see how far this rabbit hole goes. Well, I've got the board bundle out over here, and check this out. I've been looking just closer at stuff, and we can tell that these are not going to be the original capacitors, but one of the good tells right there is, you see the solder in there? Look at the solder bulbs or beams. I mean, whoever did this work before at least knew what they were doing for soldering, I think, but the weird thing is, see, there's some stuff like this. Like, what's going on here? We got, look at the size of the legs on that capacitor. And it's like, what is this person doing? This is just dangerous, bad practice. The other thing I was going to mention is these are not even, these gold Nishikon capacitors are like audio quality capacitors normally. I don't believe they're over 85 degree. Let's see. Yeah, see, they're 85 degree rated. You see that? This is not even the cap I would normally recommend even using on this project. See that, 85 degrees? So, man, this is like, somebody's got in here that was semi-competent, but I wouldn't say it's not the right person to do this job. Alright, let's look at this poor power supply, and we can see all kinds of just mess. So some things are pointless to reflow solder on. I don't know why they bothered to do this. These are just post holders for heat sinks. So those are not vital to have continuity. I mean, we can just see all kinds of poor solder that was never addressed, where you would most likely have cold solder joints on here, and then you have just uncleaned capacitors, and it looks like they were burned in. Probably some of these burned to the traces, maybe too high a heat used. I don't know. Incorrect solder. I'd kind of have to remove all this stuff and start from scratch here to figure out. Look down here. I'm not even sure what the heck was going on down here. They've got, it looks like a capacitor that they burned all the way through, and then something else. It's hard to say from this side. It says there's a diode right above it, but I think that's just the ground point, and that's the way they do a ground on there. Oh, that's not good. We shouldn't do that, okay? Really, I'm not surprised that this didn't work. I don't know what, I don't know how this could have worked. It would have been kind of a miracle, even after all this work, for it to work. I can't even tell, the quality, again, of these resolder. I mean, this, don't do this, okay? Don't install your capacitor legs like that, okay? Please. I have 100 videos on my channel about how to replace capacitors. If you're going to work on something this level, let's just do it the right way, okay? Well, I have some good news. I have spoken with the owner of this monitor, and he wants me to proceed with trying to save it as best I can. And I'm going to start by, first off, trying to get this anode cap kind of fixed up. I've been looking at it. It's tore. I don't think it's safe to use this one probably at all. It's been compromised pretty darn close to where you're actually plugging into the tube on the anode. It's probably within a ½ inch there, so that's not safe. It's smaller. This is a huge tube, But the problem is this has a sleeve right here. This is just a plastic old sleeve tubing, which is fine. But in order to get this part off, I need to get this tubing down. But if you see all this white stuff in here, this tube looks like it's got epoxy on it. So I'm going to have to cut behind this tube where it's attached and just cut the tubing, not the actual cable. I can't cut that cable. I don't want to at all. And then I'm going to have to try to cut this sleeve away and pull at that and get all that off so that hopefully I can get a clean piece of this so I can get this rubber to come off so I can pull it back, because I need this area to be kind of cleared out so I can this is like reverse I don't know, I'm gonna have to stretch that tube right there and get it around the head and slip it down over if I possibly can. I mean, this is an absolute mess. It's the first time I've really ever tried this. It's easy to salvage these. I had a shorted flyback transformer from a PVM, and so I just cut that anode cable right off and worked that out of here. Now this is a thinner wire than that, the gauging, so it's going to be a process. I'll probably have to get a tool in here and stretch that cap right there a little bit so it can make it over that if I get all that out first. But my first goal is going to be to cut away this and expose this more. So I've wrestled and gotten that sleeve part off, and that was pretty easy. This is all just epoxy. That's a little bit of the old anode cap right there. So that's what it looks like inside an anode cap. I did have to bend this. This took a while to get this part off. This is a washer that was on there. So hopefully I can get that straightened out and put on there the correct way. I don't think that would inhibit this from working, but because it just needs to make contact with the tube really well, and that's just a sleeve. But we'll try to get it back on there. It's just had to be bent to manipulate it to get it off. Now I'm going to have to tape this end because I don't want these prongs to rip my new cap. And I'm going to try to, I guess, put a bunch of lube on there and tape it, put lube on there and slide this over. I don't know if that's going to be very successful. I guess I'll just show you what happens. All right. Good news, I was able to get the original pulled off of the cable right here. I just stretched it out so it would release the cable, and you can tell it's just a piece of wire, gauged wire coming out of there, and then it's wrapped around the outside of this ring and soldered to itself. The solder doesn't bond well to this part because it seems like it's coated in an enamel, and that's the same thing I noticed on the replacement part here, if I want to use this style. So I'm still thinking of trying to use this style just because I don't know, but maybe we'll go with the original since we salvaged it and we can just save that for another day. But now I'll be able to slip that over this cable easily, and I can actually cut past all this nasty stuff. So that's what I'm going to do now, is I'm going to cut this, shear it back. Alright, here's the end of our cable. I'm going to cut it back here. So let's use these because this is give us a cleaner cut. There we go. Get rid of that old wire. Alright, so I tried to actually record myself stripping this anode cap wire and then feeding over the anode cap itself onto the old wire, but it was just really me squeezing it through the hole, and I had such a terrible angle with my camera that you can't see anything but just a pair of pliers sitting on the desk. So I'm going to skip past that footage and I'm going to show you kind of the finished product now. So let's jump ahead and I'll show you where we're at. All right, there we have it. It's pulled through right there, and the cap survived. And before I add the final cap pieces, I wanted to bring this in here and see just how much play I have, which obviously this is where it's mounted exactly right there. will be mounting point. So yeah, we'll be fine. See, we've got plenty of distance, but we're like 2 inches from being too short. So we really don't want to mess this up. We got one good shot at it to keep all this integrity together. So let's touch that fitting on this end of the anode cap. All right, here we go. Take a look at this thing. So I went ahead and did solder the braid around the outside of that, and then I pinched it onto the cable, and then I was actually able to get the washer back on there clean. And I mean, this looks exactly like it did, or it should have from the factory. So whatever happens, this is not going to be the problem. I don't know if anything else is wrong with the flyback, but at least this end, it looks good and new. I'm going to pull this sleeve over it, and then I'll show you what it looks like real quick after that. Well, here it is. It's all been refitted. I'm not overly concerned about it. Probably will need a lot of probably will need a lot of dielectric grease. Probably will need a fair amount of dielectric grease down in there under that washer, just to make sure that we don't end up with an air bubble and like have some kind of sparking going on. If there's any kind of dust under there, it'll make a lot of noise. Anyway, this is much better than what we had over here. Like I said, unfortunately, I did have to cut this cable because it was just epoxied and too worn down, and did have some compromises. But check out this. This was way worse than we even thought. It had been split clean through, and now at least it looks normal. I'm going to take a look at the power supply and some other things, and then we may set up and try to test it now that we have a stable anode cap on here. I need to isolate the power supply from these other boards. I also really should check out these ICs just to make sure that none of them are shorting on every rail to ground. And I'll be able to check those easier when I get this board out of the way. I went through and I made some tags on all these cables. They're all labeled, every single one of them, because I'm going to have to desolder 1, 2, 3, 4, 5, 6, 7, 8 cables over here, because there's no point where they're snapped in. They're actually just jumper wires that are completely soldered into the board right here. Let's try to do this J4 right quick. Get this one out of the way. I'll just still use my FR301 to heat it up, and then I'll add some fresh solder. There we go. There we go. There we go. I think that's obviously the much better way to do it. Just one more J1 right here. This dog, I know you think you're hearing that FR301, but it's really that dog snoring. So I've got that board out. It's over here in the shop, part 2, getting ready to be serviced. But as I inspect this area on these other 2 boards, which this one's our main flyback board. It's got the flyback, a couple connection points for our jumper wires. It's got looks like a transistor, a capacitor, 2 capacitors actually, and a couple other components. And actually the solder doesn't look bad on this one, but if I look over at this board, this looks like it's just got some transistors or things for power, and an isolated little board here. Check this out. Look at this point right here where my thumbnail is. Check that out. That is That is like as bad of a cold solder joint as I have pretty much ever seen. So yeah, this would, I mean, that thing is completely unattached. I'm moving it, sorry. There we go. So that's, yeah, that thing is completely unattached right there. That resistor right there. And that's coming straight from like the flyback. So maybe that's one of the problems that it kept, that were, maybe that's one of the extra problems here that was preventing it from powering on. I'm ready to start servicing this power supply. And it's definitely been recapped. But what I'm going to have to do is I'm going to have to go in and check and make sure every part's right and that it's QC'd and going and in the right polarity. I'll have to refer to the service manual parts list if I can get a copy of that. My approach is going to be to reflow the solder first on the back of this board, because my goodness, we got some cooked, scorched earth style stuff under here and some very dodgy looking solder. I can't remember where, I know there was a capacitor somewhere on this board that looked like it was not even full. There's something, right? That looks like it's not even attached. It probably is attached, but still, that's pretty bad. Well, check this out. I've been inspecting and just started reflowing solder, and I noticed that the transistors that were under these little sleeves felt a little wiggly on the legs. And look at it. Man, we have found more issues. Look at that. We have a completely snapped leg, and that was not from me working on that. That was from probably whoever worked on this prior. Again, this would have been completely covered by that sleeve, and they probably removed that shielding that was on there improperly, or the board improperly, and snapped both those K534 transistors, and the leg again here is severed on the other one. You see that? The center? Now there is a little piece of metal there, so what I'm going to attempt to do after I, reflow solder on the rest of the board is I'm going to try to just tack those together with some solder. I'll try to get those pushed together and we'll try to repair those parts. And here we have the finished board. Let me show you some stuff. It's much cleaner. All the solder's been reflowed on it. And then I checked a bunch of components, and I'll go through what I've done, but you can really see a lot better contacts on there, and everything looks clean. I've checked every joint after that to make sure everything's good. And let's see, here's those ICs I found busted. Right now I've got them repaired, and I'm hopefully just going to leave them like this to get a test. And everything else questionable on the board that I found so far looks to be okay. I tested a lot of components here and they all seemed good. The only thing I couldn't find out was over in this area. There's a couple resistors right here, 927 and 926. They look to me to have the same color pattern on them, and they're not reading the same reading though. They're 17.4 ohms, 173 ohms. So maybe they're not exactly the same and they're supposed to be that. I don't know. There's been so much wrong with this CRT. Who knows if this is the problem point. The other big issue is I did find the service manual for this, and the schematic was halfway loaded. So there was no schematic on the power supply provided. At least not one that had the values of the parts on the board. There was no board diagram. There's no part list on there. There was a part list for another board, but not this one, unfortunately. So this is really going to make things more difficult. But what we can do is, I did find a fuse on here also that I tested. What we can do is, since we've done everything possibly that we can do. We're gonna reinstall this board with the other boards and run a test with it. Alright, I pulled those two resistors I was worried about. I pulled them and tested them out of circuit, and my results were 100.3 k ohms and 100.7 k ohms. Now, according to the color code, those should be 200 k ohms, but since they're both reading 100 k ohms, I'm assuming maybe they are 100 k ohm resistors and they're not bad. So before I even attempt to swap those out or anything, we're going to just run with it and leave them in circuit and hope that's okay. I will have to keep an eye on my fixed transistors right there because they are wanting to fall apart every time I move that board. I've also gone in here and cleaned up these two boards. I've gotten all the solder reflowed on there and both sides, and then cleaned it, and then we're about to put everything back together so we can take it inside and attach it to the CRT and finally test it. Just have to put the jumper wires back in and the board back in over here, but you can see right there that's where we had a nasty cold solder joint that had developed, and that's been fixed up. Right, I've been quality control checking everything. We've got the new anode cap installed right in there. It's nice and snug. But as we look down here, everything looks fine. It's all reconnected according to the documentation. The one thing, of course, I got everything prepared. I thought I'd be able to set up a test here with coal. But of course, there's an external fuse right here. I pulled it just before I thought I'd test, and it's blown. And I'm pretty damn sure I don't have one of these here. It's a 6.3 amp, 250 volt time delay fuse. I'll see if I can find one from my local hardware store. I may just have to order one. And then we'll get it in here and try to test this thing. I'm not really sure what it is about this CRT, but every time I seem to get to a next step, something new happens. I went to the hardware store and I was able to locate the correct replacement fuses. And then I was getting ready to reinsert that fuse, and this whole insert, right there, that whole barrel insert behind there, that's the sleeve, it just literally disintegrated. And so I'm left with this spare piece of metal here and this fuse, and I don't know. I mean, this may not work. This may need to be hit to the ground. I'm not even sure whether this is going to matter. But in case it does, some miracle happens and it powers on when I test it, I don't want to miss it. So what I'm going to do is I'm going to plug it into over here, and we're going to get ready and see just what happens when we apply power. Okay, I'm going to make sure that there's no power actually connected to this. This is like push power on, so hopefully nothing's running. Because what I'm first going to do is I'm going to turn power on here, and you see we've got power there. And that's all plugged in. Now that doesn't mean anything's going to happen. Just want to see, make sure I got power over here. There we go. Good. So that means this is running. Let's just see if anything at all happens when I press this button. So I've engaged it. No response. Absolutely nothing. It's pushed in there. Okay. So whatever my plan was for the fuse is probably not correct. I found the two ends to the fuse right there. And I'm going to do something kind of not so safe. I'm going to fuse, or I'm still going to use the fuse, but I've soldered both ends in. And what I'm going to do is I'm going to have to use a ton of electrical tape and make sure I cover every bit of metal there thoroughly, because then I'll have to stuff that back in there a little bit and hold it up maybe here at this window so we can see if it blows when I get it powered on, because it's not safe to just leave it dangling like that. That would be the live voltage right there, the mains. Oh well, unfortunately I somehow missed the record button, because I did record myself powering this on, and the fuse lit up like a Halley's Comet. Burned immediately. You could see a big spark, and you can tell there that, yeah, it blew. And it blew in half, actually, from when I tried to remove it here and remove the shielding, or not the shielding, but the electrical tape. Alright, I've got our power supply removed, and then I've removed these points, these pieces. And I will tell you that, interestingly enough, this bottom line was shorting out to the top line when they were connected. And so maybe these transistors were shorted, and that's what our problem is. These are the transistors also that I removed. You can tell, I mean, it's hard to imagine these things ever properly functioning in their current condition. That one had snapped right off at the point, pretty close to the end there. And then this is another one, and it missed its leg right there. So it's pretty rough shape either way. Okay, let's put this thing down here, and I'm going to probe it underneath. And I don't believe this is just continuity mode. So that beeping just means that these are fused. So we're beeping on those two. Let's see what this does to the center. This thing, I mean, this thing right here is completely just shorted, right? It's just got 3 on a loop pieces. So that's, I mean, that's got to be busted, right? What does this other one do? Does it do the same thing? Maybe we can compare it to our new one. Yeah, see, this one's not showing continuity there. Or there. See, and let's see about these two. Or there. And it's the same part. So either one of these is partially bad, they're both bad, or whatever. Let's go get a new one and see what it does. K534 replacement. Let's see how this measures. Wow. So there you go. This one's definite, sorry. So this one is 100% bad. This one. Right here. This is a replacement. This one actually may be still good, but goodness gracious, that little node right there. The leg's just too far gone to reuse it. So I do have good news. I ran my multimeter over these points, and nothing is shorted anymore. Like I said before, since this rail, or these two things were shorted together, kind of all these rails were pinging together, being shorted. So that would make the thing just kick right off. I'm not reading any more shorts. Nothing sounds shorted, at least on this board. Like I went through and I probed and checked all these points that are different voltage points to see if any of them were shorted to ground. Found nothing. Everything else looks good on here. Maybe we'll get lucky and this thing will work. I don't know. All right, I am out here, working on putting that board bundle back in. And before I do that, I did have to remove the old fuse that you didn't see on camera, but that blew up, split in half, and exploded. And over here, I had to install this. This is just, for now, if I can get this fuse to not blow, it's in there, soldered to each point with some heat shrink tubing, electrical tape for temporarily means, so we can maybe watch it through this little window right here. And when we add power, see if it still blows up. All right, I've set up, I'm getting ready to run my test. First, I've pushed the power button in here. And over here, I've plugged everything in, power. Just waiting to plug that surge protector into the wall. What I've done over here is, in the window, hopefully I can get this in my sight. Yes, see right there? So when I flick the power on, we'll see if that just blows up. You see there? That's our fuse. I'll probably turn the lights out and do this all in one continuous shot. And I don't want to trip over anything. I need my gear, so let's go ahead. First off, make sure this is not on power on, it's on off, which is good. So plug this guy into the wall. And let me get your stuff into view right there. And here goes nothing. Just gonna hit the switch here and hopefully, oh, excuse me. All right, let me get that focused again. Okay, that's what we're looking at right there. Let's see what happens when I turn the power on. Please, baby, don't blow up. Oh my gosh. Oh my gosh. Holy crap, guys. It didn't blow up. What? No way. I heard it. Come on, boom. Oh my gosh. Oh my gosh, oh my gosh, oh my gosh, oh my gosh. I don't know how to change the input. Source select. Huh. It says it's on 01 analog. Let's see. Did I even turn this on? No, I didn't. Let's see if it comes on. Nothing. Come on, baby. Come on, baby. Show me something. Show me something. Well, I'm not getting any picture. We got the screen back. We need to figure out what's going on. All right, I'm not sure what I did. I left it in analog 1 mode because I can't get any of these buttons to change anything. But that analog 1 mode is the input over here, RGB. So I have a C-Sync cable. It's set on C-Sync, I believe. Yep. Okay, I'm going to try to mess around with this. Maybe I can get that display to go away. No, it's like it's locked out up here. Oh, well, I mean, it's working. I don't know. I think it's locked out somehow. But look at that. This thing's amazing. I never thought it would live again, but it does. I just need to figure out how to get it out of lockout mode. All right, check it out. I was fooling around some more. This appears to be some sort of a lockout switch right here, because it was all the way over in 3, which was locked, and then I turned it to 2, and now I can press things on the front and get certain stuff to pop up. Brightness mode, contrast mode. So maybe that's like a service mode or a lockout mode, etc. But man, this is awesome. Maybe like that way you can only use the remote control if it's in that way. Wow, dude, we got it to work. What a miracle. Holy crap. Well, we have a very happy conclusion here for this CRT. I mean, I was able to save it, as you could tell, and we got it out of lockout mode just then, and the last 40 minutes of video for you represented a ton of time for me. I can't explain or express how much troubleshooting time was required to get to this point where we had the CRT alive again. And there's actually more work to be done even after getting it to the point of working. We want to make sure this thing lasts for a long time. So I spoke with Randy Davis, the owner. He said I was able to shout him out here, and I'm going to give him a huge shout out because Randy's a special guy who has a huge CRT collection. He sends a lot of cool ones in here to be serviced quite often and repaired. Some of the craziest ones I've ever seen and you've ever seen. A 32-inch PVM was sent in here a long time ago, and I'll put a link to that video in the description of this video. But the latest CRT sent in is a crazy space helmet CRT. I'll tease some pictures here. Honestly, it's not even American or NTSC. It's a European television, so I don't currently even have a PAL device to connect to it, which I've got to figure out in the next couple months. But Randy is a Patreon member. Thank you very much, Randy. I can't express enough how awesome it is to have you as a client, and your support here means a lot for Retro Tech and my business. And look, if you want to have me look at your CRT, document your CRT, repair your CRT, help you repair your CRT. All those things are done exclusively for people on Patreon and Patreon members, and you can get more information on Patreon by clicking the link to Patreon in the description of this video, or going to my YouTube channel and clicking the other links section, and you can get a direct link to my Patreon. That is how I am contracted out to work on CRTs for people. But also I have a community of people over in Discord, on a private Discord server, that we're over there always helping troubleshoot things, sharing CRT listings and stuff like that. All that's available through Discord, also for anybody who supports the Patreon and the channel. So I appreciate all of you guys for doing that. Sorry for getting a little long-winded here in the this section, but what we're going to do now is we're still working on this 37-inch CRT, and as I said, we need to get it properly maintained to actually make it on a trip back home, because it's got to get professionally shipped out of the shop. So we're going to service all the remaining boards and check them all out, and that's what we're going to do now, and then we'll look at this CRT one more time and see how it looks at the end of all this. Alright, obviously I've been working more inside this monitor since we got it powered on and working and everything again. I just wanted to show you some stuff I saw on the inside layer. Now, obviously it's got this isolated beefy transformer down here that's just by itself. It's not even on a circuit board, it's just mounted to this plate. Above that plate right here is another board that I just serviced. And let me see, there it is. It's a audio breakout board, so it's good. Also serviced this neck board, as well as the power supply board and all those boards over there, obviously. And then finally I did go back and check out this board more. I reflowed solder on it because there was some dodgy bits, cleaned it up really nicely. Also checked that nothing was bridged, no parts were bad, everything else is fine on it. And over here is the bay where there's a dual setup for deflection. You'll also notice down here that I installed a fresh fuse holder. I did have the up the size of the fuse in there, but it's the same exact fuse, and it's working perfectly too. So that's been changed out and all good to go. Well, here we have these finished deflection board. I cleaned it up and reflowed solder on it. Also checked some points to make sure things were good. Everything, thankfully, is tested well once I powered it on. And so what I'm about to do now is close this thing up. I will tell you, if you ever find this CRT and you're wondering if you have it set up right, do note there's like a switch here. If that switch is pushed that way, all the way to the right, you cannot access the buttons on the front of the CRT. If we go down in this, there's a switch right there. I'm not sure what it does. It says service mode, so you can check the service manual for that. But that switch right there does something. It was in that position since I got the CRT, so if that's flipped over into service mode, the CRT probably will not function normally. So just some things to note. I didn't find any other switches on here. Everything else looks pretty normal for a 37-inch CRT monitor. Well, this big CRT is about to be picked up in, I guess, an hour. A driver has been contracted to come get it and take it out of here, and so it's all the way done, ready to go. Look, if you want a lot of specific details on everything I did, even further than what you've seen today, I'll post a show I did with Zez, where it was a live stream where we went through the entire photo gallery of about 250 photographs of the servicing done. You can see before and after of every single board inside here. But I'm going to hook up some game stuff and show you a little bit. I've connected a Sega Dreamcast, and I'm using RGB to SCART here from Edward, his lovely SCART, and then retro upgrades, female SCART to BNC, so some love for the European fellas there. Cool equipment coming from there. And what I've got is, oh man, this puts on a hot screen. There we go. Let's see if we can get some game action to load on this. Long loading time ahead. Wow. Yeah, so if I get close here, you can tell this monitor's running in 240p. We see some, you see some thick scanline definition right there. Got the shadow mask look. Obviously it's a shadow mask. Very thick scan lines in here. Definitely 240 lines. Static. We're going to finish up this video by just letting the screen roll, and you can enjoy some of the sights of the video processing on this amazing CRT display and monitor. But I do have to admit, this is an extremely rare CRT, and I personally have never seen another one besides this particular one that was in my shop from Randy. And I do know that I have seen others pictured online and displayed, and they always look great when they're working. But I do not have a lot of the specifics on total functionality and complete, like, whatever this monitor can do. I don't know all that. So if you happen to be somebody who's watching this and want to add any details or characteristics or things that I just don't know and left out about this CRT, please do note that in the comment section and help everybody out so we can document this beautiful CRT. For anybody down the road who may just happen to come across this video and want to know more about this or find one of these and want to try to save it, it's definitely a CRT worth saving if you want that showpiece, huge entertainment style or entertainment center style showpiece of a CRT. I mean, I can't think of much of a better example than this one. And these larger CRTs tend to have a lot of issues, but this one does not seem to have a lot of those issues the other ones do, where you have poor convergence and poor characteristics along the screen edges. But anyway, if you enjoyed this extra long video on repairs and how to save this amazing old school CRT, please do me a favor again and take a second to leave a like on the video. I really do appreciate you taking your time and watching this and exploring this troubleshooting session with me. And thankfully, we can move on now to the next CRT. All right, guys, so one more thing before we get out of here. If you made it all the way to this point in the video, which is the end of this almost hour-long repair video, please do me a favor and type in Brutus. I'll put the way to spell it here right on the screen. But let's go throw a shout-out to Brutus, the old king of dogs, my Old English Bulldog. Many of you who've watched the channel since the beginning remember Brutus. Unfortunately, Brutus passed away a few years back, but I never forget about him. He was here since the beginning of Retro Tech, and he used to be basically the mascot, still the mascot for Retro Tech, even though you see Cole in today's videos. He's kind of taken Brutus's place, but drop Brutus in the comments. I appreciate it. Let the legacy of the old Bulldog live on and make me a happy man. And I'll see you guys next time with some more retro content.
A wee my way, 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 a wee my way.
In the jungle, the mighty jungle, the lion sleeps tonight. Bum,